season starts here, the Vancouver Boat Show.
Welcome to the Vancouver International Boat Show virtual seminar series, sponsored by Freedom Marine International Yacht Sales, the premier choice for exploring the passion of yachting. Thank you for joining us. The seminar will begin in 1 moment. If you are having technical difficulties, you can reach me, the online moderator, via the chat feature at the bottom of your screen. Questions for our speaker can be added in the Q&A box, also at the bottom of your screen, and questions will be answered after the slide presentation. It is our pleasure to present Lithium Batteries with Jurek Makarowicz. Over to you, Jurek.
Thank you. Hello, everybody. As you heard, my name is Jurek. I'm here with Huxley. We are from Lithium Marine, and we're doing today a presentation about lithium batteries in general, then a little bit about specific lithium iron phosphate batteries by Super B, and we will finish with a little talk about the Fox Power products and another type of a lithium iron phosphate battery. So going on, what we would like to what we expect from our batteries. So we want them to be safe, we want them to be reliable, we want them to last for a very long time, we want them to be very powerful, and of course we want them to be very, very light, so after so many years of use we are able to move them. And that's where the lithium batteries come. So here are the main reasons why. If you look at the benefits of generally lithium technology versus traditional acid-based batteries. So number one advantage of lithium will be a weight. To give you the idea, in case of a starting battery, the weight of a lithium starting battery will be about 80% less than acid-based starting battery. If you go on a size, you're looking at about minimum 50% to 80% less. Another very important difference is constant voltage during charge and discharge. And then 100% capacity. 100% capacity really means that you need much less battery with lithium than you will need with the acid. Fast recharge, particularly if you have an emergency, you basically can replace all your capacity in 1 hour. And on the end, the last thing, they are very ecologically friendly. When they work, there is no leaks, there is no gas emissions, and when their life is finished, they are easily recyclable. This curve that we see here now, the lithium batteries are in red and the traditional batteries are in blue. If you look at this curve, you can see that the lithium battery basically, for up to 90% of depth of the discharge, voltage remains the same. If you look at the blue graph, the moment you start to use the lead acid battery, the voltage goes down. And after about 60%, you cannot use that battery because the voltage is already too low. Another graph that we have here, the top one shows depth of discharge versus the cycles. DOD stands for depth of discharge. So if we have 100% depth of discharge on a lithium battery, we still have about 4,000 cycles. If we go to 80%, we have 48 to 5,000 cycles. Below that, there is a AGM graph, and 100% depth of discharge gives us only about 300 cycles. And if we stretch it to under 30%, we are about 1,300 cycles. So now we will talk a little bit about the lithium varieties. Those 4 that you see here, there's many of them, but those 4 that you see here on the screen are the most common. The cobalt oxide, nickel manganese cobalt oxide, nickel cobalt aluminum oxide, and lithium iron phosphate. Here is a little bit information about each of the technologies. So the cobalt oxide is used primarily in laptops, the phones, and the cameras. Voltage per cell is 3.6. It's worth to mention at this point that the lithium batteries have 4 cells, not 6 cells. So that's why the voltage per cell to start with is high. This particular technology has a very low thermal runaway, which means that it can very easily caught on fire. Very low cycles too. You can see that's only, you can get 500 to 1,000 cycles. And also the cobalt is not easy to get. The second, the nickel manganese cobalt oxide. Primary use will be power tools, motorcycles and bicycles, some of the electrical vehicles. Again, the cell voltage is pretty high. Thermal runaway is much better, 210 degrees to get it going. And cycles are better too. It can get up to 2,000 cycles. That's about half as good as iron phosphate. The third one, cobalt aluminum. The most well-known will be Tesla, also in medical devices. Again, the voltage per cell, 3.6. Thermal runaway, very low, 150 degrees. And very low cycles. And the fourth one, the lithium iron phosphate, a lot of stationary applications. Voltage per cell much lower, 3.2. Thermal runaway much, much higher. It takes up to 270 degrees Celsius. And of course, huge amount of cycles. This table here basically shows you what we talk about it, but it's all in one. If you need any of that information, including those tables, they are available from us. Here is a graph for a density to compare different lithium technologies. LFP, which is the iron phosphate, is in the middle of a pack, and the reason that it's in the middle of a pack is not as powerful as the other technologies in the same footprint. Here we're looking at different marine battery technologies. The Corvus in blue is actually the biggest manufacturer of a marine application lithium power packs in the world. It's definitely has the most projects. The offices are in Vancouver, and most of the applications that they use are in Scandinavia, but we have some actually of the ferries now, BC ferries, not the passenger ones, but the ones that do the railway and trucks that have already Delphin energy power packs in them. You can see here density, and the Corvus is definitely ahead of everybody else. On a gray here, little Nomada 105, that's a new battery from Super B, and that's first time that Super B was able actually to come up with density anywhere close to batteries that are produced by Corvus. In a red, you see another company from Holland called EST Flowtech, but now Super B is ahead of them, still behind Corvus. When you compare the lithium batteries between themselves, there's 4 major things that you should consider. One will be in thermal runaway, which means how hot the battery gets before it basically cannot be controlled. Venting, cooling, and firefighting. So here we have a little graph. If you look at the graph on the right-hand side that shows you basically a thermal runaway, you can see that the lithium iron phosphate, which is a red, maximum temperature will get to is about 400 degrees. At the same time, if you look at the blue, and the blue can get, which is a Tesla battery, it can get as high as 900 degrees. Venting here, there is not a lot of venting, there's a little bit of venting, but again, the lithium iron phosphate is definitely ahead of the pack. Cooling. Cooling is another very important issue. The iron phosphate does not require any cooling. Now, when you have a cooling, most of the time that cooling will be water cooling, which means that you need to have extensive network of pipes, pumps, motors. and you will need to have a backups, because if you're doing a very heavy discharge or charge and there is no cooling, then you're looking very quickly into thermal runaway. As far as the firefighting is considered, again, the iron phosphate has a big advantage. The reason being is that it can be put down with water, does not require any special chemicals. Where, for example, NMC technology, when it's burning, it produces oxygen, which means that basically self-supports fire. And that means that sometimes you can put that fire down, but sometimes you just need to let it go and burn itself off. So right now we're going to have a video. That video shows the test done on a Super B battery to establish how the iron phosphate reacts to fire and how easy it is to be extinguished the fire. So we are in the fire department in Holland, special room. There's a 160 battery. There's a lot of sensor attached to it, so they know exactly when it starts burning, what was the highest temperature. Couple of burners underneath. Fire truck is ready now to make sure, just in case if something happens, they can put the fire down. First burner gets going. Second burner. You can see that the paint from the metal sides is actually melting, and slowly plastic starts to fall down. The fire is well established now. This video is speed up about 4 times, otherwise it would be way too long. But the whole process took between 10 and 12 minutes. That's it, the burners are turned off. The battery's completely on fire. You can see now that the case partially melted. You can see cells popping up on the right hand side. And this is now nozzle just with water. There's nothing else. No chemicals, just purely water under pressure. It was very quick here. They thinking that they are done, but boom, and the fire is back on. So it will require one more spray. You can see right now the white that you see, it's actually cells. The cells containers are still okay. The left one obviously lost completely its look, but the right one was still okay. So this is the end of that's the conclusion. No explosion, no excessive fire. Keep moving. So now, from talking generally about the lithium batteries, we go to specifics. Britma represents Super B, so the next part will be about Super B lithium iron phosphate batteries. Little introduction for the
We're passionate about making lithium batteries. Batteries that are intelligent, safe, reliable, and deliver high performance. We make batteries to start the engines of motorcycles or race cars with ease, even in the most extreme environments. We make batteries so you can fully enjoy the freedom of your RV or boat, or bring your industrial application to the next level and reduce CO2 emissions. We understand that when you're traveling with your RV to the most beautiful places and peaceful campsites on Earth, you will need a battery you can rely on. Or whether you sail, navigate, race, fish for fun, or on a professional basis, it is essential that you can blindly trust your power supply. You want all your equipment functioning properly, even when you are in the middle of the ocean. This is what we're good at. All our lithium batteries are designed and manufactured in the Netherlands. Our engineers are passionate to develop the most advanced batteries possible. The highest quality lithium iron phosphate cells are used to make the batteries even more durable, lighter, and safer. Our batteries are assembled not by robots, but by humans. Each component is designed and manufactured according to high-quality standards to ensure a perfect fit and functionality. Our advanced testing methods ensure manufacturing and performance quality for your everyday use. We are ISO certified, and all our batteries are UN certified, so we can deliver the necessary power for you to be in charge, anywhere, at any moment.
It's the end of our video. So now talking about the Super B in particular, the advantages of a Super B batteries versus other batteries are pretty similar than generally lithium. So the biggest advantage being weight and size, constant voltage. But one thing that wasn't mentioned before, it's integrated battery system. It's basically computer. Every 160 or 210 ampere hour battery comes with a computer built in. And basically computer hooks up to a solenoid and controls the operation of the solenoid. All your charging and discharging is after the solenoid. So if the BMS decides that value of the voltage or temperature or current is not right, it turns the solenoid off. Until that fault is repaired, the battery will not come back on the line. Of course, no cooling, firefighting, which talked before about it. And one other thing I should mention is that changing to lithium does not necessarily mean that you must change your battery charger or an expensive inverter charger. The way it works is the most common battery, the 160, the charging is very similar to AGM. Right now we have a experience of about 6 years with 10 batteries being charged by the inverter charger that does not have a lithium mode. It has AGM mode. So we're charging on that mode, and after 10 years, the batteries are still 95% capacity. Here is a little graph to make it simple. The way the charging of a lithium battery works is when the charging starts, current become a constant. So whatever the charger is able to produce, 50, 60, or 80 amps, it will produce that continuously. And the voltage will be rising from the voltage where we started to a finishing voltage, which will be somewhere around 14.2 to 14.5. At that point, the current will taper off. The balancing will happen between the cells. And when that's accomplished, the current will go to 0 and voltage will drop down somewhere to 13.5 to 13.8 volts. Here is more information about BMS. On your right-hand side, you can see the 160 ampere hour battery with a top off. And what you're looking at in the middle, the green part, that's the BMS, that's the computer system. Other than that, you can see the fuse, you can see the shunt, and you can see the rest of the cells under the red cover. So here are the values that the computer will shut down the battery to protect it from damage. So as far as the charging voltage is concerned, if one of the cells, doesn't matter which one, goes above 3.8 volts, then after 10 minutes, the computer will turn the solenoid off, which will put the battery offline. If the voltage is above 4.5 volts, then that happens instantly. As far as the charging current is concerned, 1C, C means full capacity. So in this case, C is 160. So if the charging current is 160 amps, then after 15 seconds, the battery will turn off. If the current is 2C, so 320 amps, it will be instant disconnect. Temperature. So to start with, this particular battery comes with 7 temperature sensors. Each cell has one sensor. The case has a sensor, the fuse has a sensor, and a shunt has a sensor. If the cell goes above 80 degrees Celsius, or for whoever prefers 176 Fahrenheit, the computer will turn the battery off. If the internal temperature within a case is more than 248 or 120 Celsius, or if the fuse temperature goes above 120 degrees. A good indication, the temperature factor is that, for example, if you had a loose fuse, that temperature will go there. So then the next thing you do is you will check the fuse and you'll probably find out that from vibration, possibly the nuts are loose on the fuse. Now, there's also a values for a discharge voltage and discharge current. So if we have no charging going in and we're just simply drawing the power, if one of the cells, doesn't matter how big battery bank and how many batteries you have, if one of the cells in one of the batteries, the voltage will go to 2.05, the computer will turn the battery off. And if the discharge current will be higher than 2C, so 320 amps, in 1 minute, and if the current will be 480 amps, then it will turn itself off instantly. The Super V produces 2 kinds of batteries. It produces storage or house power, you can call it, which the smallest one right now, they used to produce really tiny, but now the smallest one they do is a 90 ampere hour. That particular battery was developed for motorhomes. In Europe, that's a very standard battery for a motorhome. Then they produce 160 and 210. BMS is available from 100 ampere hours up. Cranking batteries, the ones with the orange tops, you can get them from 120 to 1000 amp pulse. The pulse will be close in equivalent to cold cranking amps that we use here. A little bit about the product now. So this is the 160. This is the most popular battery. The important thing here, which we probably didn't mention before, is charge and discharge temperatures. So you can use that battery easily up to -10 degrees Celsius and +55, but you cannot charge that battery if the temperature of the battery is below 0. Unfortunately, in that case, you will need to bring the battery inside to be able to charge it. Nominal voltage 12.8, weight in this particular case is 68 pounds. And another very important thing about that battery is that this battery has marine approvals from classification company. In this particular case, American Bureau of Shipping. So you can use it on a ship. You have certification. The only speculation right now is that they would prefer not to have it inside the wheelhouse, just in case if the communication of the battery interfere with communication on in a wheelhouse itself, radios and equipment like that. Orange top that we were talking a little bit about, that's a 25p starting battery. Amazing thing about this battery is that can produce 1000 cranking amps, which means it can start a large marine diesel, and the weight of the battery is under 10 pounds. Equivalent will be 150 pounds. to get the same cranking power in an acid-based battery. Again, the charging issue will be the same. You cannot charge it below 0, but you can actually discharge it up to -20 degrees. This is a newest product that Super B has now. It's called 105. What neat about it is that it's a newer technology. The cells are smaller, so much more powerful, and you can get much smaller footprint. What you see here on the picture on the right is 3 batteries hooked up in parallel. So we're using metal bars instead of wires, lugs, and cables. The batteries are so small that they do not have BMS built in. So what you do is you attach external bolts with a BMS and a solenoid in it. And 4 of those batteries, you can put them in any position. There is no leakage. So you can put 2 together and then 2 on the top of it. So basically that footprint of 4 batteries will match a footprint of 160. So instead of 160 ampere hours, now you're looking at 420 ampere hours. This is a 210. 210 has the same footprint of a 160, but has 50 ampere hours more. And because of the new cell technology, is only under 50 pounds. So it's about 18 pounds lighter than 160, even that has more ampere hours. Here is another sample of a starting battery, but this one actually has a BMS in. Other than that, all the information about the battery is the same, but this battery can actually control itself. If you were to have a battery like that without BMS, then you will need to use over under voltage relay, and you will see that in a presentation shortly after.
Hello, my name is Jurek, and I'm here at Breadmore Warehouse and Shop for a little talk about the lithium iron phosphate batteries by Super B and some charging equipment. To my right, orange tops, those are Super B starting or cranking batteries. The primary use would be cars, motorcycles, or start up the large engines. The big advantage, weight versus the output. So for example, this battery, 25P, 1200 cold cranking arms, 10 pounds weight. That will correspond to a D starting battery that's about 150 pounds of weight. Because battery is small, we use it with an over-under voltage relay to protect the battery from cranking when voltage is too low or voltage is too high. The connection is in series between the battery and the relay. Second thing from my right is a new product for Super B, modular 105 ampere hour battery. What you can see on the top is the connection for communication. What you see here are the buses for paralleling or putting batteries in series. And 105 ampere hours, you can make very large battery banks out of that, 22 pounds of weight. The next thing on the table is biggest seller so far for Super B, 160 ampere hour battery. This battery is very sophisticated. It has a computer inside with built-in BMS. And BMS basically does the maintenance on the battery. So BMS hooks up to one of the variety different solenoids. And if there is a problem with temperature, current, or voltage, the BMS will turn the battery off. Just for a moment, coming back to the 105, 105 does not have a built BMS, so it uses external BMS with external solenoid, which is in the gray boxes in front of the battery. If you have a large battery bank of 160s or 210s, and you are interested in seeing what's going on, you are able to do so by putting a Super B monitoring software in your computer. That software is free of charge. The one thing you need to purchase is a converter USB to CAN bus. And we're just zooming on to show you a basic screen. There's lots of other screens. If you are more interested in that, please let us know and we can set up the presentation for you. Next thing, the first thing on my left is a Christec battery charger. They are made in France. They have marine class approvals. They are DNV approved. 3 outputs. This particular model is 100 amp, 24 volts. They are also available in 24 volt in 80, 60, and 45. There's also a 12 volt model in a 90 amps. You can parallel up to 4 battery chargers if your bank is really large. And last but not least, we have energy monitors. The important thing to know is that the lithium batteries cannot be monitored by traditional energy monitors because they do calculation based on battery voltage. In case of lithium, the battery voltage does not change, so the calculation needs to be done differently, and those particular monitors can tell you state of charge for your lithium battery. That's it for now for that short video. We're going to go back now to our PowerPoint presentation, and after all this is done, if you have more questions, I'm happy to answer. Thank you.
So now we'll talk a little bit about the Super B projects. At first, maybe a little bit history. So the company started in 2007. It started as a motorcycle battery company. Then it moved to cars, and after that moved to the vessels. Right now, there's over 120 engineers actually working on the software and hardware for the batteries. Facilities, they changed already twice because they were too small. And now let's look at the projects. So at first, we just quickly go through the projects, and then there's a couple of projects that we spend a little more time with. So the first one on the right is a Tachek. It's a DC ferry. It runs out of Quadra Island. Second one that you see in the middle, that's a Danish ferry. That ferry uses the batteries for the house loads and hotel loads. And the third one that you see is the Taiwanese ferry, which is fully electric. There's a couple of tugboats and there's a couple of river boats. Now, if we go to the details, Tachek, it's a very interesting application. On your left, you see the racks. There's 54 batteries, so it's slightly over 700 volts DC. The cables that you see coming from the side, they are communication cables. They go to a large communication box that's in a room next door. 700 volts DC goes to an inverter, just simply higher voltage inverter. Inverter does the conversion from 700 volt DC to 440 volts AC 3-phase. And that powers ship thrusters when the ship docks and leaves the dock. The reason for that is that the main engines, the ship's generators running from main engines. And when the ferry slows down to dock, the engines go down in speed, generators go down in speed, and as a result, we don't produce enough power to operate 2 very large bow thrusters. So that power comes from batteries or from a diesel generator. Because of this particular operation, 4 years basically, in 4 years, the battery paid for itself compared to cost of fuel and maintenance on a large diesel generators that we need to run to operate the thrusters. That ferry operates 365 days a year and basically 12 hours every day. Right now, those batteries are in about 8 years of life and 90% of capacity is still left. Of course, I agree that here in this particular application, it is a light duty for the batteries. The next really big project that it's going on are the canal boats in the city of Amsterdam. Because of the regulations by 2025, traditional vessels that produce a lot of fumes won't be able to operate. So basically by 2025, all the traffic on the canals will be electric. The batteries on the right side here are used for 2 purposes. One is the propulsion, there's 99 of them, and other purpose is ballast because they sit in the bilge of the vessel. The Ro-Ro ferry, it's passengers and cars. all the hotel loads are on the batteries, and the generator comes on once in a while to do the recharge. Another local operation for us here, many of you maybe recognize it. It's one of the older patrol vessels for Canadian Coast Guard called Vector. Vector has emergency, because it has only one generator, it has a huge emergency battery bank, and originally that bank was 11 AD batteries on the top deck with a huge weight. That was replaced with 11 160 ampere hour batteries, so basically the weight was reduced by 50%. You can see the cabinet on your right, the batteries in a banks of 2 or 4, and they have those energy monitors, so the crew is able to tell what state of battery banks are at. That vessel is about 5 years old. Mucho Mas was built in Vancouver, actually, and all the batteries on that vessel are Super B batteries. On the right, you can see the battery room for house and emergency batteries. There's about 18 of the 160 ampere hour batteries, 2 main engines and 2 generators. Starts on the 25P batteries that you saw on the bench, and also as one of the products. Here, another Vancouver project. That's a patrol boat for Vancouver Police. It's not a big project, but it was an interesting project from point of view that environment that those batteries operate is terrible because the water shows up in the compartment. The one battery that you see on your left powers all the lights and all the electronics. Behind it, unfortunately, you cannot see there are 2 25P orange top starting batteries, and each of those batteries comes with a under over voltage relay, and they start at 400 horsepower outboards. Everything is charged when the vessel operates by the 2 alternators. One engine charges the starting battery, one engine charges the house batteries. When the vessel gets to the dock, like you see in the picture on the right, there's external battery charger that's hooked up to keep all those batteries charged up for the next trip. This is one of the older projects that we did in Vancouver. They are portable power boxes, and they are basically part of a rental company. If you're doing a little race or a presentation or something and you need some power and you don't want to pollute and run the generators, then you have ability to rent that power box. If you look at the picture on the right, the green is the 160 ampere hour battery. Right next to it, white is a 2000 watt 55 amp inverter charger. And then to your right of that, the black contour, it's actually solar panel controller and PPT. And then on the left, you can see how the box looks. So the first on the left is a plug-in. So when you plug it in, the inverter becomes a battery charger. Then you have your energy monitor, and you have 2 outlets and a light. If the batteries are on and inverter is on, then the light becomes green. And that operates now for 7 years. Now we finish basically for now with Super B and generally with lithium. Other than there's another brand of lithium that we recently start to represent. The company is called Fox Power. And here there's a little presentation from our shop about the Fox Power products.
Hello again, my name is Juraj. We are still at the Brickmart warehouse and shop. And we are right now going to talk for a little bit about Fox Power. Fox Power is manufactured in China and produces high quality lithium iron phosphate battery banks, like the one on my left, and the inverters and chargers, which is right in front of me. As far as the lithium iron phosphate power packs, they come, the smallest one will be about 100 ampere hours, the biggest one will be 1000 ampere hours. Voltage-wise, the smallest one will be 12 volt, and the 1000 ampere hour will be 48 volts. But they have a built-in BMS, they have a built-in control switch, and on the front of it you can see the lights, and depending on the state of charge or discharge, that's the number of lights that you will see. So if the battery pack is full, you will see 4 lights plus a power light. And if the battery pack is practically discharged, you only see the one light. Here we're using it together with a 24 volt Fox power inverter charger. It's a low frequency, so it's transformer based unit. This particular one is 4500 watt. And right now what we have as a setup here is we have power going into inverter charger. And from there, it goes to a battery bank, but we also have plugged in the heater, 800 watt heater, on the end, on the output of the inverter. So when the power is present, what happens is the 120 volt goes in and it splits. Part of the current goes into charging the bank and part of it goes to support the heater. When we unplug the power, so in case of a marine application, we basically left the dock. Now the inverter automatically switched to inverting. So now it's taking the power from the battery and converted to 120 volts in order to run the heater. How the conversion looks from point of view numbers is because the heater is 800 watt and the regular power will be 120 volt. So basically 800 divided by 120 volt will be about 7 amps. So at 120 volt heaters draw 7 amps. Now we switch our voltage to 24 volts produced by the power pack. So because the voltage went down from 120 to 24, the voltage went down 5 times. So to keep the equation true, the current needs to come up 5 times. So the 7 times 5 is 35, which means that right now we're pulling approximately 35 amps from our battery pack. And if I take my clamp meter and I will put it on the cable leading to the power pack, I can see 32.8. So we are very close. So that basically gives you an idea how the inverter works. Those inverters, you can have them in 12, 24, and 48 volts. The smallest one will be 2000 watt in 12 volts, and the biggest one will be 12 kW in 48 volts. Another very interesting thing about this inverter is that it has the ability to start the generator as long as your generator has an automatic start. If it does, when there's a contact on the inverter here on its left, 2 wires required, and you can set up the low voltage, and when the battery then gets to that voltage, we will send the signal to the generator to start. Now if we plug the shore power back in, our trip finished, the shore power goes back in. What will happen is, again, we'll take a moment for the inverter to realize that the AC power is on, and it will switch and start to charge the battery bank again, and this is our power trip. Yeah, oh, there it is, it happens. So it's switched now, we have a red light, which means that actually charging is happening. So we are back to the original scenario where part of the power goes to charge and part of the power goes to run the heater. When you do this application, it's very unlikely really to use that particular combination in marine. It's more like you use it off-grid, so cottage or a house somewhere. The battery bank is kind of not really movable. On a boat would be easier to do individual batteries. And if you do that off-grid and you use the inverter and the power pack, definitely one other thing you should have is solar panels and a solar controller. And here we have example of very good quality Midnight Star controller. And one thing to remember, that if you're using lithium iron phosphate batteries or any other lithium batteries, it needs to be MPPT, which means that you can adjust the charging voltage from your solar panels to be acceptable for the battery. And like we talked before, the fan just stopped, which means the lights stop flashing, which means the battery is pretty much fully charged. And as we talked on the previous presentation, to give you the better idea where your bank is at, is to use the energy monitor. that particular energy module, TBS, will keep track of your lithium batteries, or any other batteries for that matter. One other thing to mention is that if you need more power than this particular power pack, you could actually parallel those batteries. So for example, if you decided that you want 900 ampere hours, you could put 3 of those and the inverter together, and it will just give you power for longer. That's about what I have to say about Fox Power. Thank you, and we go back to presentation. Thanks.
Hello again. Thank you for your time. The presentation basically is finished. Thank you on behalf of Huxley and me. And now we will try to answer your questions. I would like to mention also that we have our booth at the show under Britmar. So if you need more information, we are available through the email or a chat if you access Britmar booth. So here are, I think Huxley has some questions.
Hi, so I'll read out some of these questions. First one, what does BMS stand for?
BMS stands for Battery Monitoring System. And basically, it's a computer system that will protect the battery from being damaged because of low voltage, high voltage, low current, or high current.
Yeah, so the computer has a bunch of sensors on the battery all over. Another question, do you need a special solar controller?
Yes, in the last video, you could see that you need a controller that's called MPPT, and that controller allows adjustment on a voltage. The solar panels are very rough as far as the voltage that they produce, and that voltage needs to be controlled before it enters the battery. So MPPT control.
Next, we have a few questions about costs. One is what is the price for the 105 amp hour batteries and general costs for recreational marine applications?
So as far as the 105 battery, the approximate cost will be about $2,100 per battery. Now, the one thing to remember is that 105 has no BMS, so you need to purchase additional box that will have a BMS and the solenoid in it. And that box with solenoid and BMS costs close to the cost of the battery. It's about $1,400 to $1,500. So from a practical point of view, I think that the 160 ampere hour battery is the best buy. It's much more power and everything is built in, so you don't need additional box. See, you're looking at, let's say, 21 to 2200 for 105 plus 15, you're looking at 37. Well, the 160 with the VMS and a solenoid is only about $3,200. But if the space is a problem, or if you really need quite a few batteries, then weight and a space, then definitely 105 is way to go.
There's a question about a specific application for their vessel. We can answer any of those questions on the booth. We'll do it one-on-one and we'll do that then. What is the 210 battery price?
210 batteries, $3,500.
Can you connect these batteries in series for 72 volt? Yes, you can.
Yes, you can. The only, I wouldn't call it an issue, but if you have a 72 volt system, then obviously you need to have a specific charger because the 72 volt would not be very common for a battery charger. And the second thing will be too that solenoid will need to be a special solenoid because Most of the solenoids that we deal with, they will be 1224, but 722 will be, but it is available. It's not a problem.
Does the 210 have BMS built in? Yes.
Yes. The only difference between 210 and 160 is 210 has 50 more ampere hours and has about 20 less pounds of weight because the cell design changed from 160 to 210.
Is there a way to shut down an external alternator regulator before the BMS disconnects the battery?
That's a little bit more complicated question. You could probably install, as far as the voltage is concerned, you can install adjustable voltage relay, and if you set up the voltage at particular value. Now, if you're thinking about battery being full, then I think that you don't need to do that. Possibly what you need to do is change the regulator. If the regulator is very crude on the alternator, you could probably, in most cases of alternators, you can change the regulator to external regulator. It just requires few extra wires, and then you can set up on the external regulator the voltage that is required. Now, another device is that if the alternator output is too high, you can put a current relay, and if the amperage exceeds certain value, the current relay will shut off.
Can the 210 be charged in the same way from a Xantrax inverter charger? Can the battery be charged from a normal Yanmar diesel jet alternator? Anything that can charge a AGM battery will charge lithium.
Yes. One thing that I probably didn't mention during presentation, which is worth mentioning, is that with regular battery banks, what happens very often is that the house bank and the starting bank can be at some point parallel together. You cannot do that with lithium. The starting battery is so different than a house battery. You can charge them from the same device. You can have one battery charger that has 3 outputs, and it will charge your starting battery separately, but you're not going to be able to join them together and charge from the same device. Right?
If we don't have any other questions, we have a few questions about, again, specific.
Are they very extensive questions? So like,
yeah, they're about specific vessels and what they need. We can talk about them. You can visit our booth, or you can call our office, and
or send us an email, or
exactly. Yeah. We can go through that one-on-one with you, and we'll be happy to figure something out. Any other questions? I don't see any.
So thank you very much for your time. And again, I invite you to come to Britmar booth. And then if you're within a Britmar booth, you will be able to talk to Huxley or myself via chat or email. Thank you.
Okay, thank you, Yurik and Huxley, for the presentation. And thank you for joining us today. We are interested in your feedback, either on this seminar, or if you have ideas on topics that you would like us to cover in the future. Simply click on the Evaluate tab located just above the seminar description and complete the form. After the show, all attendees will also receive a post-show survey. Be sure to check out all of the features at the Vancouver International Boat Show Virtual. If you have a question, check out our info booth, and certainly visit Yurik's booth as well. Have a great time at the boat show. Thanks all.
Thank you. Bye-bye.